Welcome everyone again to Mass Timber March Madness. Thanks for joining us. We have Maik Gehloff, who's going to be speaking on mass timber in BC. Maik brings a really international perspective. He's originally from Germany, worked in academia, worked in the private sector within industry. So I think he has a lot he can share on the industry. And I want to thank, before we start again, the U.S. Forest Service for their support and the Tallwood Design Institute. Ready to go, Maik?
Ready to go?
All right, thank you.
All right, thank you, Greg. Welcome to the Mass Timber in British Columbia presentation for me here for the Mass Timber March Madness, and quite a madness it has been. As Greg indicated, a bit of an international perspective, born, raised, and trained in Germany in wood science and technology, specializing in wood engineering and processing. Back in the days, they didn't even have bachelor's and master's degrees in Germany yet. So my degree is a predecessor to that. So throw that all in a blender, coming to North America, and somehow now I ended up being the acting chair of the School of Engineering at University of Northern British Columbia. And just a very quick note on that. Shaken, not stirred, please. The blender might hurt. UNBC had prior to me joining a joint undergraduate program with UBC, and then the integrated engineering program, the wood engineering program in Prince George started. That's how I really got into the academic world of things, by being one of the instructors in that program. We have since added on standalone programs in environmental engineering and civil engineering. It's gone a bit backwards, starting with a master's degree before you have a civil engineering degree, an undergrad degree that can feed into it. But that is what it is now, and we are working and are through in ministerial approval process for a Master's of Applied Sciences. So with that all said, keep in mind, I am an educator, and on more than one occasion have been told that I am actually devil's advocate as well. So much so that at times I get reminded that the devil himself might need the chance to advocate for himself. So keep that in mind as we go along here. I'm also a lifelong learner and currently also pursuing PhD studies. When I told my mom, her reaction, "You, a doctor, that's the end of the world as we know it." And trust me, my mom does not know who REM is. So mass timber in British Columbia. Where is British Columbia North America? The world would have been a little big. So British Columbia, beautiful British Columbia. What we have a lot of is trees and wood. So the move to mass timber came natural. There's been a lot of news about BC specifically, in Canada or even worldwide. Canadian mass timber to make Vancouver schools more earthquake resistant, not just more earthquake resistant, but also a little bit more sustainable. In Victoria, they started building taller building, reaching for the skies with mass timber towers, mass timber to drive the economic growth and advance clean BC. Again, BC is by and large a resource economy based on wood, and getting secondary manufacturing into BC in terms of mass timber, CLT, glulam, does promote economic growth. Tall mass timber construction gains momentum as BC's municipalities approve projects. Again, code changes now make these steps all a little bit easier, but early on that wasn't necessarily the case. BC mass timber is ready for global prime time. So interest from Google, Microsoft, Adidas, and Walmart in BC. Let's see. BC aims to grow mass timber construction and become the Harvard of green building. So we are still talking about BC. However, once you see the big players like Google, Microsoft, Adidas, Nike, Walmart, when these guys come into play, that's when you know you've reached a certain sort of state of the industry that people take notice, and projects that we have built in mass timber before become, to a certain extent, rounding errors for some of them. And Harvard, okay. So mass timber, we are still in mass timber. It's mass timber madness. What is mass timber? Well, let's see, how can we classify it? Is it volume per element? So if we look at products like CLT, NLT, DLT, GLT, so cross-laminated timber, nail-laminated timber, dowel-laminated timber, glue-laminated timber, and there is obviously more. We call them timber at the end, although they start really out as lumber, right? So volume in a project. Does a stick frame building count? Having a piece of lumber every 16 inch on center or every 1.5 inches on center to make these mass timber panels. Is it an error? Mass timber, I don't know if we have really talked about mass timber pre, say, 2000. Or does tradition have a place or deserve a place in mass timber? In BC, we have 2 CLT and GLT manufacturers. We have a few NLT manufacturers. That's very manual stuff that you can do, just nailing 2 bys together. So quite a variety of people could potentially do that. There are 2 manufacturers of DLT, one of them being predominant and fairly large. There are many, many timber framers, and log builders, there are even more. So what of that is mass timber? Does mass timber get sort of identified by the level of automation? Because mass timber, for the most part, is prefabricated. So automation, the CLT glulam manufacturers, they have automation. You have CNC machines and whatnot else. The DLT manufacturers, at least one of them, uses automation. Timber framers, there's quite a few timber framers with CNC machines. We do actually have a log builder that uses a robot, an industrial robot that used to weld together cars and builds log buildings with that. So maybe log building, the old era, has a right to be in this mix. This, the poster child right now. I think today still the largest mass timber building in the world. Austria is quickly catching up, and they're building the 22-story building. I think it's getting close to finishing, but as it stands, Brock Commons at UBC is the tallest mass timber building, 18 stories tall, although it's 1 plus 17 or 17 plus 1, so 1 concrete story on the bottom and then 17 stories in wood. There are a huge slew of buildings in BC that have been constructed in mass timber. Some are still concepts that have not yet been completely realized. Some are even like StructureCraft, the manufacturing facility for DLT, BC Passive House, an automation shop that does, by and large, stick frame panelized buildings or systems, schools, hotels and conference centers. Again, Brock Commons is actually a student housing project. So there is a ton and tons of big tall wood buildings. This one, a 12-story building in Victoria, BC, and you sort of start to realize a few commonalities between all these projects, in that they are by and large glulam post and beam with a mass timber deck, in this case an NLT or DLT deck, and I'm going to look into that a little more detailed in a few slides from now. Even fire halls, the biggest concern that people used to have and still have is fire in wood. I mean, it's sprinkled, of course, but it's wood burns, but fire halls are so confident in wood that they build their structures out of wood. They're so comfortable with them, though, that they even start jarring the outside of the fire hall. So, I don't know if that sends the right message, but they do. That jarring of the outside is actually a very effective way of protecting the wood. Usually done slightly different than this, but it does protect wood. The Earth Ocean Science Center at UBC, on the UBC campus, one of the first buildings to actually implement CLT panels. Again, you see glulam post and beam with CLT panels. One of the biggest features in this building, however, is the staircase with some gluten connectors. There are no ropes, no nets, no safety nets. This is actually a cantilevered stair system that spans the entire way without any supports and these individual landings of that staircase. And it is pretty sturdy. People might think there's a bit of a vibration concern there. It is actually a pretty sturdy staircase. Projects are being talked about and conceived all over the place. We don't have to build salt boxes or square buildings. I mean, wood can be shaped in just about any form. You can see that with some of the renderings and concepts that are out there for ever more projects to be built. And here again, if you peel the curtain wall system, similar to what Brock Commons did, if you peel that away, you see again glulam columns. In this case, the columns are actually supporting a CLT deck, which due to its ability to span in two directions as a two-way slab, you can actually do that. There is some services run in these panels, but again, you have glulam posts, sometimes beams, and then mass timber decking, concrete toppings. Sometimes it's a wood concrete composite that is used for the decking there. Glulam post and beam, big, huge sort of show pieces, statement pieces, steel braces. This is for lateral stability. They couldn't get enough shear walls into that building. Well, if you need to put something like that in, make it a feature. This is the MEC store in Vancouver, similar to the REI, I believe it is, in the US. Again, glulam post and beam with, in this case again, NLT decking for flooring, for the floors. Here again, glulam post and beam. And one thing that you also see in all of these pictures, and which I want to point out, that we are stacking columns on columns, because as we go tall and going to 12 and more stories tall, cumulative shrinkage between the side grain here in the beams will cause the building to significantly sort of reduce in height if you accumulate that over 12 or more stories. So by stacking the columns on top of one another, there's very little to no shrinkage in the length direction of the wood, so that individual floors might shrink slightly, but that shrinkage is not accumulated throughout or across all floors. Again, Brock comments, glulam posts, and again, due to the use of CLT, they were actually able to just use glulam columns. They didn't need beams because CLT can span as a two-way slab and can support at a certain grid spacing. You can actually get away without having any columns or any beams. And you see these little connectors on top of the columns here, where the CLT panels are essentially dropped over top of these connectors, and the next column sits inside that and then continues on, so that you again have a straight load path from column to column without having to worry about the shrinkage and the thickness of the CLT panels in this case. And for machining as well, this is around HSS, for instance. Drilling round holes is super easy to do with machines, because tools are cylinders. Making something round, very easy. Don't go and try to make it rectangular or square if you don't have to. Some other civic buildings here, like a pool, I believe this is in the Vancouver area. A school, as the headline said early on, Vancouver School District is using schools. This is the Bagby Elementary School that is complete glulam and CLT, the entire school. They have another school on the way, the Bayview Elementary School, that has also a lot of CLT and glulam in it, but it is not entirely CLT and glulam. I guess the Vancouver School Board didn't want to chew off more than they can, or bite off more than they can chew. Rendering of a project in Langford on Vancouver Island. This is a rendering. That building is I think for the most part up, if not completely finished. So wood being used all over the place. Soccer stadium, grand stands of a soccer stadium, again in Langford, British Columbia, just finished a project delivered actually by a European glulam manufacturer, but we are using wood in just about every way, form, or shape. The Olympic speed skating oval, I mean, who doesn't know that? Vancouver 2010 Olympics, that was one of the big legacy projects. We have the skating ice all the way around, and the inner part of it is sort of a flex space you have set up for badminton right now, but you see nets for handball or indoor soccer, whatever they might have played in there. We have a V-shaped glulam arch, so it's actually two glulam beams that's sort of in a V that allow for services to run, and then connecting to big concrete buttresses here on the outside to take the thrust. And at that point in time, the mountain pine beetle, that little critter, caused a lot of havoc all over British Columbia, Canada in general, and partially the US as well. But pine beetle killed wood was what was used in 2x4s in these floor panels that have been constructed, pre-assembled into 4 or 5 ribs at a time, and now being placed as roofs up here, that again they are curved in one direction, but they are by and large V's in the transverse direction, in the length directions. again, allowing for services to be run through that. And looking at that one beetle, how much havoc it raised in most of our forests, it was also pretty much the starting point, or one of the big reasons why CLT potentially actually got as big as it did, because at that point in time, we had so much fiber that needed to be used in a certain amount of time that CLT was a venue, a vessel, something that you could sink a lot of fiber into. Why otherwise would you, put a CLT wall up where you have a whole lot of lumber in it, when you can use a stick framed wall where you have lumber every 16 inch on center, right? But we had enough of that wood available. It needed to be used. Structurally, the beetle killed wood was not a concern. It was more of a visual thing. However, after a certain period of time, and some people threw timelines of 5 years out there, it needed to be gone, because then you got into the point where it was no longer structurally viable. But we have done things like that prior to big investments like that. That's a pool Invest Vancouver that has been using the glulam roof structure here well before the 2010 Olympics or the mountain pine beetle pandemic. And I'm using the word pandemic here very carefully, as we all know in our current global situation. It sometimes strikes a bit of a nerve. But North America's tallest wood building opens in British Columbia. That is the Wood Innovation Design Center in Prince George, British Columbia. It actually used to have my office in it. I'm now in a slightly different office, but this building houses our wood engineering program. It was the tallest building in North America at a time. It's officially 6 stories because there's a mezzanine story here. So this counts as 1, 2, 3, 4, 5, 6. However, structurally speaking, with that mezzanine level in here, that's actually 2 stories. And due to the angle of the photo, up on the roof, there is a mechanical penthouse that's also done in wood. So structurally, it's actually an 8-story building. So that was North America's tallest wood building, right? It opened Halloween 2014. I know that because that was my first official day at UNBC. It was a Friday. Why would somebody ever hire somebody on a Friday on October 31st? Why not November 1, right? However, that was when the building got opened. So I moved straight into the open building, into my office there. So 2014, North America's tallest wood building. Steamworks Pub, love that place. Vancouver. How many stories is that? I mean, that's the front, that's the back. It drops off a little bit below here, and that from that parking deck here. So if we count this out, 1, 2, 3, 4, 5, 6, 7, 8, 9 stories tall. And especially in the dark, you see it even better. You can actually see that this building has beams and wooden decking in it. And if you go inside, well, now talk about mass timber. Those are some significant columns. They get smaller as you go up in the building, but solid saw, not glulam, post and beam with, and if you look in the corner here a little bit, an NLT flooring decking. That's a 9-story building that's been there for about 100 years. How can the 8-story building essentially in Prince George 2014 be the tallest in North America? But now let's just look back at details. What have they done in the past? They knew that if you're stacking beams, especially if you have your main beams and you're stacking secondary joists over top of it, and you have your NLT decking on top of it, that over 9 stories, that building has potential of a lot of cumulative shrinkage. So what did they do? They put steel connectors in here so that they can, as you can see here, bear column on column. As you go higher in a building, you're using the steel one to just pick up the ends for bearing on these joists or main floor beams, but the column from the top level or next level up bears on the one below. Here it's more of like a metal cage that then picks up the column on the top floor. And then as you go even higher in the building, these connectors start changing a bit because you don't need that bulk anymore. You lighten your load as you go up in the building. So you have still a steel connector that supports a column, the column from the next floor up, or the roof beams, whatever it might be at this very top level here, with just a metal strap essentially to keep these beams in place. We are in a seismic zone here, so we have to make sure that these beams can't slide off their supports. So when we look at that, about 100 years or over 100 years old, yes, this is something that now can be cut much easier with machines. Even welding these was probably a lot different job than these guys were, but by and large, we haven't really needed to reinvent the wheel. We just needed to look around us, right? So we have a steel connector that allows us to pick up the next story, the next column above. So is that the holy grail, the new invention? I mean, hopefully they had a beer when they talked about it and looked up and saw, hey, look at that, let's do that. However, and here is now sort of my pitch, if I was to build or run a mass timber factory of sorts, CLT, whatever it is, this type of building, that's a Vancam, a trucking terminal, again in Prince George, British Columbia. It flew under the radar until I actually, for some reason, got lost and needed to ask for directions, walked in there to ask for directions. I didn't even know it existed. It is a glulam post and beam building with CLT walls. An industrial building that has been built in CLT. How many of these buildings are out there? How many Brock Commons are going to be out there? How many of these super largest, tallest of anything out there? This is taking a bite out of tilt-up concrete. Tilt-up concrete isn't, glamorous or anything like that. They're efficient, and they're as the most efficient as long as their walls can actually rest entirely on the floor below it. So when a building of it's around about 40,000 square feet is where tilt-up concrete really thrives. If it gets smaller than that, you have to pour the one wall first, tilt it up, pour the next one to tilt it up. So you can't sort of be as efficient as they can be when the buildings get bigger. There's a big opportunity for mass timber to just do that. That could be a cash cow. That should be the cash cow. And it allows us to go into a bit more sustainable construction in these everyday buildings. That's hundreds of thousands of these buildings around. They're getting torn down and rebuilt all over the place. Since this building has been up, Prince George has built at least 30 of those buildings. So again, it's not trying on needing to be glamorous, but it just seemed to have made sense, right? Codes and standards. We have improved on that. BC allows up to 12 stories, and that talking going higher and higher. But BC threw a new wrench into the whole works here with what they call the step code. What is the step code? The step code is a sort of an envelope performance type or building energy performance type code. And it is called a step code because there's 5 steps to it. And by 2030, I believe 2030 or 2025, whatever it is. But in the next few years, that step code, it's not calling it passive house, but it has similar identifiers or indicators like passive houses. It's got to do with air tightness, the insulation values, obviously, depending on where you are. So step code is going to require a lot of buildings to be super airtight, to have a high insulative volume or value, so that in Prince George, Vancouver, we are no longer prescribing you have to build a 2x6 wall with R20 or something, regardless of where you are. You actually have to model the building and build it according to the geographic location that you are in, with sunshine days and days of minus or below 0. So there's a whole bunch of work that has to go into that. So this is now, again, a chance for mass timber, but also something to keep in mind, that we need to be able to build airtight envelopes with our mass timber. We need to make sure that, and we can always add insulation to the outside, but there can be, we have to keep that in mind. So step code is actually going to be challenging, not just wood, but every building in BC going forward a little bit more. Can we mass timber do it? Yes, that's the Wood Innovation Research Lab in Prince George. That is where my office is now. This is a glulam post and beam building with the roof is open floor, open joists here, wooden joists, but it is a certified passive house. This entire building is a certified passive house. It's almost broke a record for air tightness compared to smaller buildings, but it is incredibly airtight, and it is an incredibly high performing envelope. When you look at the wall thickness here, I think the walls are 16, 17 inches thick, because we're in Prince George. I mean, we get temperatures down to minus 40 centigrade. So mass timber has every chance and every opportunity to do it. We just have to detail it accordingly and appropriately. So trying to sort of wrap this up a little bit so we have a chance to chat afterward. The always used elevator pitch. If you can't get something across to somebody as long as it takes to ride the elevator, you might have lost them. So let's see how tall the building is that we have our elevator right here. Or maybe we should take this thing here, a paternoster. Remember these things that they're continuously moving and you just jump in and out of it. And when I showed it to my kids, people go up. So if they don't jump out on the top, they come down back upside down. No, they don't. But yeah. So, but it's not going to be that easy. We're not just going to talk about elevators. So a few more projects here in British Columbia: visitor centers, libraries, schools. Again, a visitor center. It might actually be the same one there. Hockey arenas, and not just Olympic legacy arenas. This is an arena built after the Olympics that is just a community arena that wasn't there, was built in mass timber because that's just what we do now. It doesn't become this steel, open joist steel building. The pool in West Vancouver we talked about earlier. SkyTrain stations, so infrastructure projects. Pedestrian bridges in Vancouver. Again, school buildings. The Prince George Airport. How much would I have loved to be at that airport and join this event in any way, form, or shape in person somewhere and come back to this airport and to Prince George. But even, again, infrastructure buildings, airports, there's more airports now that utilize wood than just Prince George. But that was one that was a slightly larger building already that is done in wood. So what was it that my mom said when I told her that I'm going to get my PhD? The end of the world as we know it.
Thanks, Mike. That was a really quick tour of all the things going on in BC. And I actually would like to begin. I have a couple of questions, if you don't mind.
Yeah, go for it.
And we have Stefan on. You're originally from Germany. Stefan's from Switzerland. We last saw each other in person at Holzbau in Innsbruck in 2019. The demand is there in Canada, right? I think we're actually setting housing price appreciation records again. And the market's crazy strong for construction and wood and real estate in the US. How is the supply chain evolving if all of that demand is there, and engineering, that's your specialty, compared to how things have evolved in Germany, Austria, and Switzerland? Can you just give more on your international perspective?
Yeah, I think the international perspective is a bit of a tricky one. We tend to take things out of context sometimes, right? The way that wood is sort of shopped around in Europe, like how the European manufacturers buy their wood or deal with selling wood, is way different than it is in Canada and even in the US. In Europe, CLT has not risen from mountain pine beetles, or because of one project in Europe, the Stadthaus in London, that the first 9-story wood building in CLT, that sort of piqued interest for North America in CLT. In Europe, it was trying to compete with single-family brick residences. So CLT wasn't this huge commercial thing. It has morphed into it. It has morphed into it, maybe even by and large because North America has only started adopting it once it started to go tall, once it became more than your normal stick frame building could hold up to. But Europe they have a lot of the technologies when it comes to connectors and systems like that. They have been researching CLT for years. CLT has come from glulam manufacturers that have their low-grade lamellas that couldn't make it into glulam manufacturing. They needed a sink for that. Whereas in North America, that's not the case. We don't use low-grade lamellas that we can't use for glulam production in CLT production. We are actually putting a whole different type of material in their prime material. So lumber prices since COVID, at least here in BC, have gone through the roof. I'm not sure what pricing has done in the US, but in BC, I mean, prices for lumber have increased 60+%, and there's talk out there that it will keep going up for a little while to come. Part of that is, I don't know how much the pandemic actually had to do with it, but a lot of it is also wildfires that we kept having, the decrease in available volume. So we're going to have to start thinking about these types of situations where we need to look at efficiencies in our materials. And a lot of times that's done. The NLT, the DLT, that's a try to make certain aspects of mass timber more efficient, because the structural height of NLT or DLT is actually for a beam span is more efficient than CLT. However, when you have these block comments or the buildings, the concepts where the CLT is either cantilevered on two directions or supported simply supported on one beam on a column, then the NLT DLT wouldn't really be the right material to do that. You need the columns below that. So there's a lot of things, that directions that can go, but internationally, Europe, I think, is still leading the way. They have much more sophisticated production facilities, although the newest facility, Kalashnikov in southern British Columbia, they have one of those European type lines, so they are a little more efficient with that. But in North America, we still have to sort of buy into this becoming a commodity. I mean, how much commodity glulam? There is a lot of commodity glulam in the US, but there isn't as much of that in Canada. And I don't know if there's any companies really that make commodity CLT. I mean, sort of, I think the differentiation really is the commodity of things. In North America, we're going project based. In Europe, they went volume, commodity, but then added on projects into the mix. But they gained the efficiency from the commodity industry into their projects.
Perfect. And you mentioned BC with its resource-based economy. It has so much wood. It's got a strong real estate market. If people target lower buildings, where the real volume is, as you gave that example of the truck stop, how big potentially is the market if efficient systems can be continued to be developed? Like when you're talking with your mom, when you're talking Germany, it's not her area, but let's say you're talking to colleagues in Germany, or you're just speaking in German to people within Europe, and they're like, wow, you've got all that wood, you've got a strong real estate market. How big potentially is the market for mass timber in BC and North America, just from your view?
I mean, the market can be anything it wants to be. These tilt-up concrete buildings that are, say, below the 40,000 feet, it's going to be a little trickier to break into the really efficient sizes of these markets. But if we stop shipping, like if we build all these buildings out of CLT or mass timber, finding efficient systems is not going to be an issue once we start building those. I mean, we are starting with the really, really tricky stuff, right? 18-story buildings, something we've never done before. And going to these 1, maybe 2-story tall buildings, they're not necessarily actually have 2 floors in them, but that should be a lot easier to go there. And our resource-based economy ships still a ton of wood into Asian markets, for instance. So we have the volume, the fiber volume is there. It is just building the capacity. Like even now with the second company coming on board, there is so much capacity that is required, that can be there, that can be tailored. But we need to stop looking at our competitor being the other glulam guy. We need to look at the tilt-up concrete, the steel buildings, or the light frame steel buildings as our or the most competition. When I talk to my family, to be quite honest, half the time they're asking why wood, why not concrete, right? Like a concrete type air trained concrete that has the thermal efficiencies that are required in Europe, where they have these thermal codes a lot, or energy codes a lot further. But they're still believing in this. It has to be solid, something hard, something really, really substantial. When you're going more into the Alpine regions, southern Germany, Austria, Switzerland, that's where wood has always been more traditional, and that's sort of where it is thriving and where it mostly came from, that whole development. Sweden, the northern regions of Europe, northeastern regions of Europe, that's where some of those capacities really lie. And again, they just took it as commodity. They have it a little bit easier. If you really look at the market, Europe in terms of land mass to population compared to North America, I mean, Canada especially, the US still has 10 times the amount of people at least that Canada has on a similar land area. But in Canada, distances are just so far between things. You have your hotspots, the Bacon Belt, if you will, or was within 100 kilometers of the US border. I have friends living in Michigan that live further north than 80% of the Canadian population. So there's a lot of land, there's a lot of resource. There's a lot of these projects that can be built with that resource. So we're not going to run out anytime soon. We just have to sort of spike the appetite a little bit. A lot of people still don't believe in wood. Wood is something that goes into your fireplace, or we send it to Asia, right? So we had a thriving furniture industry in Canada 10, 15 years ago. That's all gone overseas because we ship logs instead of finished products.
Well, since you're teaching engineering, I'm going to ask another question along those lines. Rather than exporting logs or, let's say, commodity lumber, if automation is used and the efficiencies there, couldn't secondary wood processing or higher value-added services really be a boom for the BC industry? Because you're not shipping commodity product, you're shipping essentially kit of parts, prefab buildings.
Absolutely, and that's BC is trying to push a little bit towards that to get into secondary manufacturing. I mean, it's not as easy as flipping a switch and having that on board. The BC Log and Timber Industry Association has actually done a little bit of digging and looking at how much value they add to their process. And we're talking about log buildings and timber frames by and large. Some of them do panelized projects, but it's more the smaller companies. But with a fraction of the fiber, they're creating multitude of times of jobs and economic growth in their respective small little communities. So if we make the shift and ship finished products, like may that be a commodity glue lump, that's one step more that's been done, one more step of value adding that's been done in BC or closer to the resource, rather than sending the logs to China or the 2x to China. If they want to build CLT, just send them the CLT, for instance, right? So BC has a huge potential in terms of being that thriving economy if we truly get from primary into secondary, and true secondary, using the lumber, not just the planer mills or anything like that, but actual companies that do either prefab stick frame building, buildings, CLT, glulam, DLT, NLT, whatever it may be. There is a lot of potential for the amount of fiber that we have, and we can still sell enough fiber to Asian markets afterwards, or alongside that.
And yeah, sorry to put you on the spot, but that's, I guess, my argument. Often my father at 82, finally I convinced him to retire his sawmill. Both of my grandparents had sawmills, but when I'm having the discussions with people like, well, why automation? Why technology? Is that good for the wood industry or is it bad? It's my argument is it's the thing that can really create more jobs than anything else by doing more local value add. There's an economic and an environmental argument for that. But what would you see as the biggest impediment to that happening? What do we need more of so those jobs and industries thrive?
Sorry, go ahead.
Well, you're the interim chair of the School of Engineering, but if Mike had far more power and say, hey, we can make this industry thrive, what do we need to do?
Okay, so one of the things is feeling, right? People, that's what people work for us. That's who does some of the jobs. By automating, people always think, as you're saying, it takes jobs away. I approach it, and I teach a processing course here. To me, a CNC machine, a robot, whatever it may be, is nothing else than a tool. It's just a little larger than your hammer or your power drill that you stick into your tool belt. And as you're saying, there's efficiencies to be gained. I can use a handsaw, like not a motorized handsaw, like an actual handsaw, and cut sticks into studs and build walls, for instance. Now I have a plug-in tool that cuts 10 times the amount of sticks, however quick I am, or chop saws. Did that take jobs away? People didn't complain about that. It made their jobs easier. It made it better for them. They cranked out, for a number, 10 times as much material. Now, if I do that with a CNC machine that has more than one tool on board, and it's being programmed to do something, it is just a tool. I still need somebody to now design plan, because there's a lot more pre-planning going on that needs to be done, building digital twins and BIM modeling and what might else. So job descriptions might shift slightly, but you can actually employ or need to employ a lot more people that way. So the first part is the human factor in terms of machines don't steal jobs or robots don't steal jobs. They actually help you. They make your work less laborious. That's where the word robot, the word robot came from laborious word, robota. But they help do your job, do a better job. You are it's a lot more ergonomic. It just improves your work environment, right? The other part, to a certain extent, is misconception still. A lot of people see a prefab building and think trailer park. Not so much in mass timber and CLT, but with stick frame buildings, there's stigmas. There's like, I don't want to live in a trailer park. I'm not, no way I'm going to spend that. So there's some of those perceptions. But I think one of the still key problems in my mind is code standards and jurisdictions. In Canada, at least, every building has to be inspected at framing level, insulation level, so that the building inspector needs to see the insulation or the wiring before he can close up a panel. So now we're doing prefab with open panels, for instance. If you do closed panels, you have to hope that a building inspector in his jurisdiction allows you to do so, goes along with it. You build a building across the street where a different inspector is in charge, you might not be allowed to do the exact same thing there. You can get CSA in Canada or in the US, probably an ASTM type certification for your factory process. However, then you are licensed and certified to a manufactured home standard, and that comes with the stigma of trailer park again. So a lot of the companies in BC specifically, they stay away from certification because they don't want to be certified to something that doesn't actually represent what they're doing, but has a certain stigma attached to it. If you Google websites, when you look at their statements and what they try to tell you when they're trying to sell you their products, a lot of them are trying to talk away from prefabrication. They're trying to guide the eye away from like even being planned. Like, if it is automated, if it's built by a machine, it's going to be a box. All of them look the same. They're actively trying to divert attention from the fact that it is somewhat prefabricated by still trying to highlight the advantages of it, like cost savings or better cost planning, scheduling, being having a lot better time management, lost time on site to snow and ice and what might else, especially in Prince George. There's so many goods about it, but there's still so much effort on trying to answer to the small little things that are historic based. I mean, trailer parks came from travel trailers. By now, a trailer has to be built to the exact same standards and codes as regular on-site built homes. The insulation values, it's no longer just a 2x4 with no insulation. It's a regular wall that any other house would have had to have. So I think there is still a perception that needs to be sort of worked on. And again, that's the human level. So you need to convince humans twice: A, that machines don't steal jobs, and B, that living in a manufactured home, a prefabbed home, is actually not a bad thing. It's actually a good thing.
Well, I think there's so much compelling architecture. Let's use as an example, Spearhead does amazing buildings out of wood. And when I look at some of those buildings, or we saw Fabian Scheuer's presentation, Design to Production, I mean, intuitively, you look at that, you couldn't do that using manual processes. The geometry is just too complex, and you certainly couldn't do it cost competitively. And as we have more buildings to reference of timber that are prefab, if I move beyond the question of certification, I think there's a growing market where people say, wow, that is a smart, efficient, good way to build. And that fact that you have to use advanced technologies to do that just kind of intuitively makes sense. But that's my question. I've read a couple of them from the audience. It's here's one from an anonymous attendee. Do you know of any restoration adaptive reuse examples in BC using mass timber?
I think we are still in the phases where we still build new buildings. I mean, I've shown you that that large building in downtown Vancouver, in Gastown, Yaletown, like the older part of Vancouver has a lot of these 8-story plus buildings done in timber. There's not so much reuse. I mean, there is a reconfiguration of the space itself, but I think we are too early to say we're gonna dismantle a building and use components of that building to put it together in another building someplace. I think it's way too early for that. Our buildings are usually designed to last 60, 80, 100 years and longer. So I'm not sure if restoration and adaptive reuse, other than maybe reconfiguring a few interior walls, that you could have done it in regardless. And that's maybe even the point. It just because it's timber, yes, the timber building eventually allows you to potentially take the CLT panels, recut them and put them in another project. But again, I think it's too early for that. We are not at a point where any of those buildings that we have built these days is at the point that we take it out of commission and make something else out of it. I don't think there is an example in BC yet.
All right, here's a question, Lech Muzinski will be one of our speakers coming up. I just want to draw attention to the one he mentions. Austria has been sending CLT projects to Australia. That cannot be as hard as it seems. Do you have a comment to that?
It is not, and we have sent BC, or I don't know about maybe not US manufacturers yet, but BC or Canadian manufacturers have sent projects overseas. It is not hard. There's Vancam Terminal, that was an Austrian CLT manufacturer that sent it over here. There's actually quite a few buildings in BC that are mass timber that came from Europe. So that it's not hard at all, and it shouldn't be hard for North America. Again, that's where the efficiencies come in. When Europe is more efficient in cranking out the projects, then price-wise, they're going to have a leg up on Canadian competitors. However, what Canada has a leg up on, and especially the West Coast, is species like Douglas fir. Like Europe doesn't have that. In Europe, most of what you get is either pine, but by and large, it's spruce. So there is certain factors that we could try to exploit a little bit more. And projects have been sent internationally. Structural Lam has done projects overseas. Structure Craft with the NLT or DLT type buildings, they have done stuff overseas. It's easy to do. It can be done.
And I just want to, Daryl Patterson from Lend-Lease will be presenting on the 27th, and I think Lend-Lease is doing amazing mass timber around the world, including in Australia. And it's interesting to watch, how does their business model evolve, and how do many companies' business model evolve? Is it the vertical integration model, where they're trying to do almost everything, or does it make sense in that specific geography to focus on specific activities, value adding, as opposed to total vertical integration?
That's a good point, and a lot of the there are CLT manufacturers in Europe that don't have the vertical integration from the fiber source into the mass timber projects. But in Canada, we have two. We have Nordique and now Kalashnikov that are vertically integrated. And there's a lot of talk about these projects being delivered, and how to learn how to adopt for general contractors that used to build these tall buildings in concrete and steel, something that they're very familiar with. Now they're shifting to mass timber and needing timber framers, lock builders to help them put them together. So there is something to be said for complete vertical integration. However, the commodity market, and that's sort of some companies in Canada now too, but especially in Europe, they're doing this. I can be the designer, the director of the building, the engineer, and then I go to market. Whether it's in Europe, it's KLH, Binder, whoever it may be, Haslacher, I can buy my CLT in the market from whomever gives me the best price. So that, I think that part, that makes sense as well, but you do need a certain level of vertical integration because of the slight nuances to mass timber projects that a lot of the big general contractors are still learning these days. That will hopefully better itself, but there are still processes that need to be learned on the end of the actual delivery of these projects, where the vertical integration makes a lot of sense. And buying the product at market might be the one thing that is the easiest to take out of that vertical flow.
Well, thank you. Here's a question from Luciano Tagliaferri. Would you please explain again the difference among DLT, NLT, and CLT from the strength points of view?
Yeah, so DLT and NLT, I don't really differentiate in terms of strength. One is nailed together, one is put together with wooden dowels. So they're, for all intents and purposes, there's not much, if any, difference in strength. The difference between those two, DLT, NLT, and CLT, is the cross lamination. So you have, in CLT, you have layers running in two directions, 90 degrees to one another. That means you have capacity in two directions. So you have one strong direction and one weak direction, but it does take load in that direction. Whereas an NLT can only be really loaded as a beam type with two supports on either end. It doesn't really want to take slab action. The efficiencies in terms of strength points that I mentioned is that because the lamellas or the layers of the CLT are not all running in the same direction. So in your loading direction, you have most CLT, well, all CLT is odd numbers of layers. So say in a 5-ply, you have 3 layers running in the strong direction and 2 in the weak direction. And those 2 layers in the weak direction participate very little into the strength in the long direction, in the actual stronger direction. So you have a thicker panel than you would have if you have the DLTs or NLTs where all the beams are oriented the strongest direction, but only spanning in one direction. So that gives you the efficiencies there that you need less material, less thickness in these panels. And we see for a lot of companies now a shift to the cross layers actually being 1 bias instead of 2 bias to minimize that slight inefficiency when loaded in beam action.
Beautiful. Thank you for being put on the spot like that and having a quick and good answer. Well, I'm going to just kind of end. We're coming up on the hour. But I want to leave, if people want to follow up with Mike and keep track of what's going on in BC, what do you kind of recommend? Because not everyone can take your classes, even though you're teaching them virtually. So just to keep aware, what any recommendations for resources, or both for you individually or in general for what's going on in BC?
Yeah, I mean, if you look at the UNBC website, you find contact info for me. So feel free to reach out that way. We are actually working, and that again is one of those economic growth programs for BC. We are in the process of putting together what they call it, what BC likes to call, the province calls a retraining program. So if you're coming from the resource industry and need to sort of retrain and to get into other aspects of now value adding mass timber, we're going to start putting together a variety of online and some in-person classes on various aspects of mass timber or wood construction in general. There will be modules and elements on the modeling, the 3D, the digital twin. There will be some on processing, there will be engineering modules. So that gives you a chance to keep up to date with the newest developments in the industry as a whole. When it comes to BC, I think really online, I mean, there's so many projects on the go in BC that I lose track of some of them. Like sometimes like, oh, have you heard of that? Yeah, there was talk about it. How well that's done now. So it's up. So it's really hard to keep track. And some of it doesn't actually get celebrated the same way anymore, which it's sad maybe for them, but I actually like it. This Vancam terminal, nobody cared, but that could be a bread and butter projects. I personally, do I need to be the tallest, biggest, widest, deepest, whatever it is, mass timber project? No, I just need to make sure that my mass timber projects are being delivered and that my product is out there. So that's getting a bit quieter. There are some websites that try, especially for tall buildings, that try to summarize actually globally what the tallest and the biggest mass timber projects are worldwide. So there, I don't even know what's called, the Tallwood Institute that Greg mentioned. They maintain some level of oversight of what's going on worldwide in that. I think those channels are probably best. And then you sort of do how I get myself into trouble sometimes time-wise. You get from one link to the next, and all of a sudden you're in a completely different direction than you actually started out. I wanted to look up one thing and ended up looking at something completely different. So I think it's mostly look at the educators, maybe these Mass Timber City type websites. They usually have good resources or links to resources, and just sort of take it from there. And there is UNBC There is Oregon, the Mass Timber Institute, they're going to start putting some courses on that you do not have to have a bachelor's degree to take those courses. So that is coming because there's a need for that in the industry. The Red Seal carpentry programs, they have to change because by and large, we are not framing on site anymore. With the step code, as I mentioned in BC, try to get super airtight buildings built on site. That's almost impossible. So there is a need for this to happen in a factory, whether that's fully automated or partially automated or completely done by hand. That's not the biggest concern there. But once you're in a controlled environment, you may as well add the automation and really take it to the next level.
And I have, this is, I kind of finished. We've taken an hour of your time, but I have one more question just for me, if you don't mind. In talking to people about mass timber or even CLT here in Oregon and or Washington, often it's seen as something that could really kind of save the wood industry. I don't know how much it needs saving right now, given the extremely high prices. But so often they're only looking at is how do we create a commodity product? You know, like if we're going to convert, now we're going to switch from glulam to making CLT, but they overlook the value adding processes around that above simply producing a commodity product that almost always requires further processing.
Yeah, and that's one thing that I don't know why we haven't done this much. If I'm in Germany, I can go to a hardware store and buy glulam off the shelf, like I buy lumber here. And that's once we have the commodities, we get these timber framers, these carpenters starting to use these commodity products and adding even more value to this, to these elements. So by creating commodity, it's one more step in refining the product. It's not just sending lumber to China, wherever it is, but you then give the next entity a chance to work with it. We are running out of old growth forest with these big mass timber columns that I showed in this in the pub there, the Steamworks building. So once we have commodity, glulam, CLT, you will start having carpenters and timber framers start buying these commodities and further refining them into mass timber projects of all shapes and sizes. So there definitely is a need for it. We need to be able to answer to the market. We bring this huge awareness, but if the 2-3 companies that exist that can do this are not being able to keep up with it, who's going to wait 5 years to get their mass timber project delivered? They're going to go conventional. So being able to have commodity products that the mom and pop shops start building and participating in these projects as well, and building more and more capacity in this and the complete process is essential for this industry to really thrive and go into the next decade, century.
Well, thanks for your time. We're up on the hour, Mike. I'll try to get this video up on YouTube to share. And thanks for sharing so much great information.